All right, thank you for joining everyone. This is the last meeting of the year for the AppliedAI meetup of Minnesota. So we've been meeting for just about 2 years with various discussions on applying artificial intelligence in business, in all kinds of different technology, in research, in developing software. But this is our first that's a little bit less applied. This is about using artificial intelligence to generate art. And it's a topic I'm really interested in. I don't work in it professionally. I don't think anyone does really at this point, because it's a very rapidly emerging field. Maybe a couple of researchers at universities or something are get to do this professionally, but for now, it's all people messing around in their spare time with technology and trying to figure out how to use the latest artificial intelligence algorithms to create art. So before we get started, if you go to this link, you can follow along, and I'd actually like everyone to do that if you have a moment, if you have a second window, just because there are links in the presentation that then go to useful things in the outside world. So I'm going to type that into the chat window. I have to mute every time I type because my keyboard is really loud. All right. So that should show up in the chat, and you can just copy and paste that into your web browser. So there's this old question, which is, can computers make art? People have been asking this since pretty much computers were invented, and I just pulled up some old examples just so we have some a little bit of history here. This guy Harold Cohen was trying to use computers to make art actually in the 60s. So basically, as soon as the first vacuum tube computers were invented, he was trying to create algorithms to make art. And then this is one of his later pieces. He actually just recently died. So he started early in his career and early in the lifetime of computers as a thing. And just fascinating stuff. He was able to make algorithms where you could type in person wearing a green shirt, and it would actually draw a person wearing a green shirt. And then he actually made robots that would paint this with physical acrylic paints on paper, because back in the 60s, I guess color printers hadn't been invented yet. And even in the 90s, they probably weren't that great. So he had little robots that could crawl around on a big canvas and draw paintings like this. Just amazing stuff. And then one of the most famous things in this realm that ever happened is in 1984, an AI author called Racter wrote a novel. I'm using air quotes here if you can't see me. The novel is called "The Policeman's Beard is Half Constructed." You can buy it on Amazon. It says the first book ever written by a computer. This was a lie. People have gone back and tried to figure out, if the software that was available at the time. I mean, he said the programmer said he ran this on an Apple II. There's just no way an Apple II could have generated a book like this. Like, it's a book that makes sense, that is mostly logical, even despite being called "The Policeman's Beard is Half Constructed." They actually sold software called Racter that you could install on your Apple II. It did nothing like this, though. It just basically generated random words. So this was a scam, really creative scam, but it's also really famous because the hype around this was just incredible. There were newspaper articles and magazine articles and documentaries about this amazing program called Racter that could write a novel, and it was a lie. So, and you're going to see this come up a lot. Many of these things tend to be hype and tend not to be real. Unless someone can explain how something works, it's probably not real. And then AI music. People have been using computers to try to generate music actually since the beginning of computers as well. If you remember in the movie 2001, remember when they're killing Hal, and Hal starts singing "Daisy, Daisy, give me your answer true." Remember that part of the movie? That was actually based on a mainframe computer that learned how to play that song roughly around the time that movie came out in 62 or 63. So there's a lot of history around people messing around with computers to generate music. Obviously, right now, having a computer just be able to play a series of notes doesn't seem all that complicated, but it really captured people's imagination in the 60s. And there was some very serious work around writing software to take a body of music, like all the pieces written by Mozart, and generate new music. This was a book about that topic in the 90s. So people have been fascinated with AI to create music for a long time as well. Any questions on this? This is sort of the background material. Okay, so there's a lot of hype. So before we get too far into this, a lot of what you'll see if you just Google AI art, you'll see a lot of people making algorithms that only have a very narrow range of output. So they can't really do that much. Some of them, I've heard AI called copyright washing. So you put in something that was created by a person, and then it just like changes some words for synonyms, and then it's basically exactly the same thing as came in. So you have to be really careful about that. Then this is maybe the most common thing you'll see if you read articles about AI online, is people will run some program that generates jokes, okay, and they'll get 50,000 jokes, and then they'll skim through them and pick the top 10 best that kind of makes sense. So you've got to be really careful. If someone doesn't explain how something works and they don't provide examples of it failing, then they're probably just selecting the cases where it worked. So you've got to be really, really careful. And then there's also just fake scammers, scammers like the policeman's beard is half constructed. There's a million YouTube videos that are like, a robot wrote this movie. Oh, this was a good one. This is a digital assistant that writes better notes than a doctor. This is a company that sold a supercomputer that takes medical notes to the government of New Zealand for like $10 million. It never did anything. It was literally just a person writing the notes on a keyboard. There was no software involved. It was just a total scam. So you see this kind of thing happening a lot. So before we get too far into this, just be a little bit skeptical. When we say, can computers create art? In some cases they can, in some cases they can't. Every time you see something, remember that they're probably trying to sell something. So you've got to be a little bit careful in this space. But ideally what we'd like to see is, first of all, we want to create something unique that people find enjoyable. I think that's the best definition of art. Is something, it has to be unique. It can't just be a copy of something that already exists. And it has to be something that people find enjoyable. I think that's the definition of art, whether that's a movie or a book or a poem or a song or a TV show or a painting. It has to be something people find enjoyable. Okay, so that's what we're trying to get to. Ideally, first of all, we have a bunch of training data that's out there in the real world. We have stuff that was created by humans. If you go to Google image search and type in beautiful oil painting, you can get 50 million of them. Then you'll have some algorithm that takes that data and summarizes it into something called a model. And a model is a piece of data that encapsulates all that wisdom from all that human created work. And then you want to have something called an inference algorithm. This takes that model and generates that new thing. So this is a program that takes the model and generates that piece of art. Maybe it takes a prompt or some tuning to be able to do that. So this is ideally what I would consider some kind of AI that can create art. Is it takes training data, has a learning algorithm that hopefully is published somewhere, has a model that hopefully you can download, has an inference algorithm that you can hopefully try on your own computer, and then get something out that's unique and enjoyable. Enjoyable, obviously, depends from person to person, but hopefully it's something that most people would agree is interesting to look at or listen to. Are there any questions here? All right. I don't know if I can see the chat window if people do type.
I'll be watching for it, Daniel.
All right, great.
I do have a quick thing, I guess. I just kind of came to mind. You see those algorithms that can stitch together people's faces, right? It's a face that's completely unique. You may find it enjoyable or not. With it, would you consider that as artwork? I guess that type of algorithm that built that.
I definitely would, and I actually have that as an example a little later on. So there are these algorithms that will generate a unique face of a person who doesn't exist. And I would definitely consider that art. Anyway.
Right, great.
Yeah. Any more questions? Okay, so I talked about the history, the 50s, the 60s, the 70s, the 80s, the 90s. Gave some examples from way back then. There have been some big breakthroughs in the relatively recent past, in the 2010s. So the first big thing that happened is a bunch of computer science academics created something called ImageNet. And what ImageNet is it's a set of, right now it's about 15 million images, and every single one is labeled in a computer readable format by humans. So there will be a picture of a golden retriever, and they'll type in golden retriever, and they'll say its eyes are here, and its nose is here, and its fur is here, and the background is this. And if it's a golden retriever, I don't know, eating an apple, it'll say, oh, and there's an apple here. And this is all labeled. There's actually a staff of about 25 humans who sit around all day labeling images. Sounds like a really boring job, actually. And they've been doing this for more than 10 years. Like I said, it's about 14 million images now. It's all funded by Google and Microsoft, the big tech companies. So then the next thing that happened is, ImageNet created a contest to do the best image recognition algorithm. And the one that really started to stand out is something called a convolutional neural network. So convolution, if you're familiar with like linear algebra, what it means is taking a small image and multiplying it by every point in a big image. That's all it is. It's a fancy word. And there's some evidence that when your brain is identifying images in the real world, or things that come in through your eyes in the real world, your brain is doing some convolutions on these images. So applying a bunch of very small images and multiplying them by every point in what's coming in through your eye. So there was some scientific evidence that maybe this was a good direction to go. And then we had GPUs that were available because the gamers demanded GPUs, and we got a bunch of really fast GPUs. And it turns out that if you run a convolutional neural network on images, on the ImageNet data specifically, these convolutional neural networks were consistently winning all the ImageNet challenges for labeling images. So you put in a photo of a golden retriever eating an apple, and the convolutional neural network would scan a bunch of little tiny images. Maybe one of them is fur, maybe one of them is a dog nose, and it will identify that this is in the image. Maybe one of them is an apple skin. It will identify that those features are in the image, and then it will use those features to produce some output, and that output is, hey, it's a dog eating an apple, which is really cool stuff. Oh, my monitor just turned off. Just 1 second, sorry. That was weird. I'm sorry about that. My monitor turned off and I think it stopped sharing my screen.
You're still sharing.
Oh, okay, good.
Oh, no, you're not.
My screen sharing, it says my screen sharing is paused. I didn't intend to do that. Sorry about that.
No.
All right. Can you see the whole thing?
Yep.
Yep.
All right, good. Okay. So then we've got these, so then what happened in 2014 was a new technique called generative adversarial networks was created. And I've got another slide on this a little bit later. What this is doing is it's taking a recognition algorithm and it's turning it into a generation algorithm. So you can recognize that dog eating an apple. But what I want to do is, for artistic purposes, is create a new picture of a dog eating an apple. So this technique called generative adversarial networks had existed for a long time, but it became really popular with some papers in 2014. And then in 2015, Google project called Deep Dream came out, which made these pictures like this by using that generative adversarial technique. It would basically randomly generate images, feed them into a convolutional neural network, see if they identify as interesting images and continue to optimize and tune that until it gets some kind of picture like this. So this made a huge splash, partially because it was Google, and Google has really good marketing. And they made a ton of pictures like this, which blew up the internet way back in 2015. The generative adversarial networks technique more broadly, you can has been used to make faces like this. And someone used it to generate a fake portrait. This one, Edmund de Bellamy. This is actually like a really dumb pun because Bellamy in French means good fellow. And the scientist who invented generative adversarial networks, his last name was Goodfellow. Anyway, this sold at an auction at Christie's for $432,000. It was sort of a publicity stunt. It was the first AI art that was auctioned as if it were an actual painting by a real person. I don't know. I'd rather look at this than at this, but this is the one that sold at auction for a lot of money. Any questions so far?
We could call that money laundering.
Yeah, it probably is. It probably is not. It's not real money, would be my guess. It's kind of ugly, but oh, and over here in the corner, it has like written down a bunch of equations, which were the equations that were used to generate the image. I don't know. It's total publicity stunt, like Banksy type stuff, where they do provocative things for money, but I guess it was successful. But the key idea here is that if you can recognize art, if you can recognize something that's interesting to humans, maybe using that convolutional neural network, then you can generate art, because you can generate random stuff and keep feeding it into whatever method you have for recognizing things. So bullet point here, people have invested a lot of effort over a lot of time into developing algorithms to recognize things. Google has spent billions of dollars on this. Microsoft, Amazon, all these big tech companies have a vested interest in having algorithms be able to recognize things, and we can recycle those algorithms to generate things, generate art. So as long as you have some method that can tell whether something is a face, then you can generate a face. As long as you have a method that can tell whether something is a weird Renaissance style watercolor painting, you can generate a weird Renaissance style watercolor painting. As long as something you can tell whether something looks like a weird psychedelic dream, you can generate something that looks like a weird psychedelic dream. And everything else I'm going to be talking about today is based on this idea. Are there any questions so far? Right. Okay. So like I said, a convolutional neural network is this process for recognizing images. So I certainly wouldn't expect anyone to understand all of this or even 1% of this, but it's important to be familiar with the very basic concept. So if we're trying to recognize something like a zebra on this left side, it's got this tiny fragment of zebra fur in its memory, maybe just 10 pixels by 10 pixels, very tiny. And that's called the kernel. And that is, the convolutional neural network looks for that feature in every picture it sees. And then it feeds that into some kind of a feature vector, something like this. And that goes into a neural network, which is trained to classify images based on those features. So you might see some problems with this, like if you have I don't know, a zebra skin purse, I don't know if that exists, or a zebra skin couch, it's probably going to recognize that as a zebra because it has no idea where anything is in the image. It just knows about features and what those features look like. And zebra is a really good example because that fur is very distinctive. The stripes are very distinctive, but these features come up all over the place: eyes, noses, mouths, tree leaves, all kinds of different features that are in pictures. And that seems to be how humans recognize things, at least at first glance. Although I don't think any human, if you looked at a zebra skin couch, would think it's a zebra because you recognize that those pieces are all out of place. The computers are not that smart yet. So then, like I said, there's this database of images. That's a widely accepted public free database of images. So it has all, here are just some random examples I stole from the ImageNet database. This one is, you can see the label is building, sky, plant, tree, travel, urban design, natural landscape. Okay, so it's obviously a palace or a hotel or something like that. I guess it has a swimming pool, so it must be a hotel. This everyone knows is a shark. So the labels are lamniform shark, requiem shark, jaw, etc. And actually, in the full ImageNet database, it also says where those parts are. So this part would be labeled jaw. This part would be labeled eye, probably. So we've got this database of millions and millions of images that, fortunately, it's public and anyone can download it. You have to request permission that everyone is standardized and using this training database. And then what you can do is you have two of these networks. One of them takes random noise and generates images, and then one of them is set up as a discriminator. So this is trying to decide, is this classified as a real image or a fake image or a nonsense image? So if you have a classifier for sharks, you feed in a bunch of noise that generates a bunch of things that probably mostly don't look like sharks. And then the discriminator decides, hey, this looks like a shark, or this doesn't look like a shark. And then through a long process, this discriminator can be tuned to generate things that look more and more and more like a shark. In this example, it's generating a face. So you've got a bunch of faces, you've got a face generator, you've got this discriminator that says, hey, this looks like a face, this doesn't look like a face. And then eventually what you get is you get a neural network that's really good at generating faces. And you get a face like this, which I couldn't tell isn't real. I don't know about you. It looks really good. And if you go to thispersondoesnotexist.com, it'll generate a face for you in real time. And you can look at those faces, and most of them are really good. Occasionally you'll get one that definitely doesn't look like a person, but that's pretty rare. Most of the time it works really well. Are there any questions on this? So I linked to a sort of a very detailed blog post that goes into exactly how this technique works.
Hey, Daniel, this is Justin. I was just going to say, so it's the training part that takes a long time, but once you actually have the model, what you're saying is you can run through and generate these faces pretty quickly. Is that true? Yeah,
it's fairly fast once the model is developed. Especially on these big GPUs that the professionals have, they can run millions of iterations per second. So.
Interesting. Yeah, and I guess you're going to want to make sure you have a variety of real faces.
Absolutely, right. Yeah. I mean, if you put in only people of a certain ethnicity or whatever, you're only going to get that output. So the training data really affects the output, and you definitely need to keep that in mind.
Yeah. Cool.
And this is just a couple of examples of cases where it really doesn't work, because I think this illustrates better what's going on here. So it's totally based on features. So it has no way of understanding that, like, usually if someone's wearing an earring, they have the same earring on the other side. Like, that's something humans know. There's no way for this GAN technique to understand that. And it also tends to mess up hair, but I don't know if that's intrinsic or it just needs more samples of hair. It often gets eyes wrong. It often gets like mustaches wrong, like things that don't appear very often in the training data. I really think that earrings is the most illustrative, and also like ears. I mean, like, her ears are obviously totally different. Each ear on its own is probably fine, but the neural network has no way of knowing that, like, people are usually mostly symmetrical. It just knows about features, and it knows about where those features usually come up together. And here I just extracted some pretty pictures from one of the papers on GAN generated artwork. So they fed a database of art in museums into a GAN and ran it, and you get a bunch of art like this. These are actually just select ones. So they had a group of humans then rate the resulting artwork, and you get stuff like this. I've got a couple slides of it. It's kind of boring, but if I saw that hanging on the wall of a hotel, I wouldn't look twice. I'd say, oh, hey, that looks like art made by a person. Okay, so remember back in the beginning of the presentation, I said that we would want to have some kind of a prompt, some kind of a way to control the output. Well, to do that, unless you want like a slider that just controls, the contents of the image in some way, we want to be able to process words, and words are also obviously they're a very important part of a lot of other kinds of artwork. So we need some kind of a model to talk about words. And that convolutional neural network, remember, it's looking for like small images in a patch of big images. It doesn't even, it doesn't really translate to words on a page. It just only makes sense for pictures. So again, here, there's a whole bunch of history. People have been trying to create models for languages for a really long time. It's very hard. And then also there isn't as obvious a commercial application as for images. For images, it's obviously very useful for a computer to be able to identify the things in a picture. Maybe you can identify things that are going wrong in a factory. You can search a database of pictures. Language models, maybe they don't make as much sense commercially. So in 2015, a nonprofit group called OpenAI started. One of their founders was Sam Altman. One of their other founders was a guy named Elon Musk. They got over $1 billion in funding to start up an institute doing research on language models. And that was 2015. And they started with this type of model called a transformer. What a transformer is it takes a bunch of words and it transforms them into other words. That's all it does. It learns the association between a series of words and a series of other words. And here's a diagram of how it works. I don't understand this at all. Honestly, this stuff is actually a lot more complicated than the image processing artificial intelligence, if you ask me, because a lot of it is basically experimentation. They add components and see how well they work, and mess around and change parts and see how they work. And it's very empirical, I think. So OpenAI took that transformer model and they trained them. They trained a transformer model first called GPT-2 in 2019 and then GPT-3 in 2020. They took gigabytes of published books, and also they downloaded essentially all of Reddit. So if you've ever posted anything on Reddit, it's probably in this database. And they spent a lot of time and money training these massive transformer models on huge supercomputers. Again, this sort of got a lot of hype. This was a New York Times article. Meet GPT-3, it has learned to code and blog and argue. That sounds kind of like the policeman's beard is half constructed from the 1980s, doesn't it? At least I thought that was like ridiculously overhyped. But anyway, they've developed these models. I'm sure GPT-4 is what they're working on now. GPT-2 you can just download. It's completely open source, so it's used all over the place. GPT-3, they've kept secret, and you can only run it on their servers with their API, and you have to pay. So that one isn't used as often. So now that we're talking about language, we can experiment with using language models to write things. This is someone who literally typed into GPT-3, please write me a 14-line rhyming sonnet. And you can see it spit out something that kind of makes sense, until you actually read it. It doesn't actually have anything to do with the topic that they put in. It's just kind of almost random words. They also tried putting in joke prompts. This is the same person. So they typed in, the first part of a joke and tried to get the punchline. These like kind of make sense. Like you can see where it's coming from based on the a database of writing, but it also doesn't. I mean, they're not funny jokes. Only one of these is actually like slightly amusing, which is, what is brown, hairy, and wears sunglasses? A sun bear. Apparently, a sun bear is an actual kind of bear. I didn't even know that. But it's a sun bear. It wears sunglasses. It's like kind of funny. I don't know. How does a vampire start a letter? Dear blood. Like you can, like it kind of makes sense. Like blood is definitely an associated word with vampire, but not that associated, right? Anyway, but then this is an example of it working really, really, really well. This is an example of that language model doing writing really, really well. This is taking the first paragraph of Harry Potter and then writing it in the style of different authors. So Ernest Hemingway version, Jane Austen version, and Arthur Conan Doyle version. And these are basically perfect. So this is a case where it worked really incredibly well. This is, I don't know, I thought it was really funny. So it seems to work really well for some types of situations, and maybe not for other situations. Are there any questions about this? I can sit here for a second and can't read the whole thing, but you can read the first little bit. Also, if you go to the slides, you can click that link and see this whole thing. It's this person has probably 100 pages of examples of GPT-3 writing things. And then this is a game I really like called AI Dungeon. It's a text-based role-playing game that uses GPT-3 to generate its text. And it's actually really funny and really interesting. So this is a real company that, I don't know, they got funding, they charge money. So you can go to this link here from the slides and try it out. Okay, so circling back to image generation, OpenAI also created a model called Clip. And what this does is it takes an image and generates text. So it has some kind of a language model that's based on, I think it's GPT-2. And it can take a picture like this, and it says, it's a photo of guacamole, a type of food. I have no idea what's going on in that picture, but that's the kind of thing it can do. Here's a group of people playing volleyball. You can tell it's a volleyball net, and it says a photo of a person volleyball spiking. Seems like it works pretty well. I mean, I could tell that's volleyball, but I had to think about it for a second because there's a bunch of people and there's a volleyball net, but there's also a bunch of other stuff going on in this picture with some Chinese text and some fans. So seems like that works pretty well. And remember, if you can recognize something, then you can generate it. So I've linked to two Google Colab notebooks. And what these do is they generate images using this clip model and using a GAN. So they use these are two different people's work. And they're in Google Colab, and you can click here and generate a picture. And I'm going to go through some examples in a minute. But if you make one while I'm talking, just email me and then I can show it on the screen, or you can just show it on the screen yourself. Most people are using Google Colab to mess around with this kind of art generation. And the reason is these use like a ton of GPU memory. It would be really expensive to do on your own hardware. So Google Colab is a service where you can borrow Google hardware in order to run machine learning models. And it works really well. They've got a free tier, and then they've also got one that costs $10 a month. The free tier is actually really good. So you probably don't even need to pay $10 a month to try this. Okay, actually, I'm going to show you the notebooks. So this is the second one I linked to, and this is the first one I linked to. So you can The way you run this, first of all, you want to basically download everything that's necessary to run the notebook. So you hit runtime and then you hit run all, and then you wait for probably about 5 minutes for it to download all the required components. So you wait a bit and then you type in a prompt in this thing. And I typed in a dog eating grapes. I don't know. I guess I'm not that creative. And it generated this picture, which doesn't look anything like that. So this is a case where it didn't work super well, I guess. But you could type in some different phrase here and see what it creates. So here's some artwork created using that method. This is all actually, this one is by the guy who made that that Collab notebook, sort of as his example. This is pretty cool. Death of a hacker. I guess this is coming for all of us, right? So you typed in death of a hacker as that prompt and got that as output. The revolution will not be televised. This is a different person who was using the same Collab notebook. This is one I made. I just thought this is fun. This is for the Marvel movie Black Widow. So I typed in that expression exactly and got that output, which is really interesting. It's like, I could actually see that as a movie poster maybe. So are there any questions so far?
Daniel, somebody just mentioned that in the slides, the second link, I think it goes to needing access. I think you have to request access.
Oh, it shouldn't. That was not on purpose. I'm just going to click share here and maybe I link to my copy instead of the public copy. I will post the real link, the correct link. And there's nothing secret in here. I certainly wasn't trying to hide it, but that might be my modified version instead of the public version. You can also use the first link. So it's two different people who I think were working together, but they made slightly different Collab notebooks. I guess there's also this one. I haven't even tried this one yet. And this is combining the GAN method plus the clip method. So you can type in language and get art as output. Okay, so I don't know how to share computer sound. I've never tried this before. Sorry. I guess I'm not going to be able to do this, but you can, in the slides, you can play this for yourself. But the same transformer technique that's used to generate language for language models can also be used to generate music. And I posted a couple of examples here. This is another Collab notebook that generates music. And they explain exactly what they're doing. And then this is actually a startup that is planning to make like soundtracks for movies or TV shows probably, or ads or something like that, by automatically generating music, background music. And they actually have a whole YouTube playlist of like really surprisingly good music. They have rock concerts and fake classical music and all kinds of different stuff that was all generated using transformers. And because it's a startup, they haven't really announced exactly how it works, but you can still listen to it on YouTube. Are there any questions? I'd really encourage everyone to play these YouTube videos on your own computer because it's really impressive. Sorry, my computer's trying to play them. All right, and then this is the last sort of topic I wanted to mention. This is maybe one of the parts of AI artwork that I think will be most successful in the short term because it basically works the best in practice. So this is you take an image and then you take some kind of a style image, and it identifies the features in this, and it tries to recreate this image using some of the feature elements from this image. So I actually did this just today. I put in a picture of a dog. I put in a picture, the famous wave painting, and got this. And it actually works really well, really consistently. I think this will probably be really popular, just because it's super easy, it's fast, it's really consistent. It's a little bit of a different technique. It doesn't use the GAN method or the transformers or the clip models or anything like that. It's a sort of a different area of research, but I think this will be really popular because you could just take a picture and then stylize it in whatever style you would like to.
Dan, quick question. What exactly is a style image?
Oh, so it uses the stylistic elements of this image to generate the stylized image. So as you can see, it uses the color palette. It uses some of the features like this, the blue here that's in the wave is sort of getting copied into the blue here of the fur. So you could put in a different style and get a different result, I guess. Does that make sense?
Yeah, it kind of does. So I guess what you're saying is that the original is still going to be mostly original, which just accented with the style.
Yes. Yes.
Okay.
So the shapes will be the same in both, but the features, the style, the little the colors, the little elements that actually make the shapes are copied.
Very cool. Thank you.
I really recommend playing around with this because I think it's one of the, I have it open here, but it seems to have timed out. This seems to be like one of the most consistent, easiest ways to get started with AI generated art. I don't know, we could put in a different, I think because it timed out, I have to restart it. So this may take a moment. Oh, they have other examples actually built into the notebook. So here's a turtle, and here's the style image, which is the screen by Munch, and you get the turtle painted in the style of the screen. It's pretty cool. Or I could change it to apparently that one. I don't know. Let's see what happens. So you can tell it's visibly the same turtle, but it's painted in that style. Or I guess Starry Night. Visibly, it's that turtle, but painted in the style of Van Gogh's Starry Night. So like I said, this is really consistent. It's really fast. I think it's maybe the best way to get started with AI art. And I think this is going to be really popular, maybe even just in a year. If this is included in Photoshop or something, everyone will use it, right? So I've linked to a couple of tools. This is just to try in your own time, but Gogan is this is attempting to be basically Photoshop, but for AI generated art. I haven't really figured out how to use it very well yet, so I'm not gonna get into that. But it's definitely worth trying. And then Snowpixel is another site that's kind of similar. There are actually a bunch more that you can probably Google. People have realized that this whole family of methods has a lot of potential, so they're all trying it out and trying to make money with it. So here are just a bunch of resources you can check out in the slides. And then I guess to close things off, it's what does the future hold? So I think that probably easy stuff will get replaced first. So stuff like hotel art, office art, I mean, that could already be generated automatically, like instantly. I think that's probably going to happen. Elevator music, hold music, the music that's playing in an office or something, that could be generated. ads in magazines, there's already a bunch of companies in the space that are trying to make customized ads or summarize sports games really quickly, automatically, with no human input. So you put in, the Vikings scored 7 or whatever, and it automatically generates a whole news article based on the factual events that happened in the game. And then, in the slightly longer term future, it'll be a tool for the creators. It'll be a tool for the people making music and TV shows and movies and everything that we consume. I think Adobe is very aware of this. They're going to integrate it into Photoshop. They're going to integrate it into Adobe Premiere or whatever. But then the long-term future is where it gets really interesting. Will I ever sit down in front of the TV and watch a TV show that was completely generated by an AI? I mean, some shows like I've been watching Seinfeld lately, Seinfeld reruns. I think that could be generated automatically, and probably no one would notice because nothing really happens. That could complicated plots and characters. Even just realistic human beings talking to each other. When is that going to happen? And I don't think anyone knows yet, but I think it's on the horizon. So with that, thank you very much. And I guess we have some time for discussion. I definitely recommend playing around with these notebooks because they're just really fun. Any suggestions for something I should try to generate here? Anything? Okay.
Hey Dan,
Mhm.
it's Jake. Hey man.
Oh, hey.
Hey, I was gonna say a dog eating grapes would actually be a poisonous image because
Yeah,
grapes are toxic to dogs. So maybe
that's probably a bad example. Yeah, probably not a great example.
No, go ahead, Dan.
Oh, and like I said, this notebook, the fast style transfer one that I linked to also. This is maybe the best way to get something in just a few minutes that's pretty much guaranteed to work really well.
Neat.
Oh, sorry.
No, go
I
ahead.
was gonna say the fast transfer seems very similar to an app called Prisma. Have you ever checked out Prisma?
No, I haven't.
Yeah, so it's a mobile app.
Oh, okay.
Might add to it. I'll post a link in the chat here.
Yeah, it takes
cool.
your photos and adds that kind of stylized layer over them.
Mm-hmm.
Yeah, and it's probably using something like this, but
Yeah.
because it's a commercial app, we probably won't know for sure exactly how it works.
Right.
I think Deep Dream even did that at the beginning where you could like
Mhm.
upload your profile photo and put it in the style of Picasso or Modigliani or whichever famous artist you wanted,
Okay. Yeah, I think this probably has the most direct applications because you can. It's so fast and it tends to work really well.
Looks like an easy way to generate some Christmas gifts.
Yep. And then if you go on Twitter, the hashtag people are using seems to be VQGAN, which is one of the GAN methods. And there's people posting their art all the time. And I always watch this hashtag just for, of course, there's people spamming with their random stuff, but there's some amazing stuff that people have created. I mean, it's hard to believe that wasn't made by a person, but at least they're saying it wasn't. So I definitely would check this out. Cool. Well, with that, I'm done.
I was going to ask one question, Dan. I don't know if your research this probably feeds more into what an attorney would know, but I mean, I will say in my experience, as I was like looking to get music for our podcast, I went to some of these sites and had some music generated by artificial intelligence, and it was really good. I thought it was really good, but it was not free, right? So the creators of it, we needed to pay, and they actually were asking for some pretty hefty sums for it. So when it comes to this stuff, have you seen like who actually owns the rights to the stuff you're seeing on the screen?
Yeah, I think that's an open question. I don't know. So if I use a site to generate some music or art or whatever, I imagine that that's theirs if they claim it. But if I download a program and then use that program to generate something, can they retain copyright on the thing that was generated? I don't know. I would think not. I mean, if I make a picture in Photoshop, it isn't the property of Adobe, as far as I know. So.
Right. Sure. Yeah, it's interesting. I just started thinking about all this artwork that's going to be generated in hotels and office buildings or whatever you're saying. You're right.
Yeah.
It is pretty low hanging fruit, but is someone going to profit from that?
Someone will. I just don't know who. So
yeah, right.
There are a lot of startups in this space, and I'm sure they all have their own way of monetizing. None of them are really successful yet. So I guess we'll find out. Cool. Well, thanks for listening, everyone, and keep in touch. Share the art you generate. If you get a chance to generate any, we can post it on the meetup page.
Yeah, please do. And I put a link in the chat earlier on, just to our Slack channel, as well. So I'll post that on the meetup group as well. But want to continue the conversation, of course, in between our meetups, and we'll be meeting again the first Thursday in 2022. But thanks, Daniel, for showing us really, really cool stuff going on here in the world of creativity and artificial intelligence.
Thanks, everyone, for joining.
Before we head out, I want to know, Daniel, what's your pride position? What's your favorite artwork that was created?
My favorite that anyone has created? Or
I mean,
that
it's AI, so you did not create that. So.
Oh, true. I don't know. So I made this Twitter handle. This was a couple months ago, where I was just posting the cool stuff I made. I didn't want to spam all my like regular Twitter followers with stuff. So I retweeted some stuff, and I also made some stuff myself on here. Here, sorry, one moment. Looking for one that not that I made, but that I pushed the button to make. Some of these didn't really work. About maybe 1 in 5 really works. I don't know, something like that is pretty cool. I didn't make this one. This is something I had reposted, but I don't know. I've been trying to share the ones that I think are really good. I don't know. I should have selected a few beforehand. Yeah, I'll be sure to post more in the future, though. Cool. Well, thanks for joining, everyone.
Excellent.
Thank you so much.
Yeah.
Thanks, Daniel.
All right.
Thanks,
you for
everyone.
sharing.
Next
Thank you.
month.
Yes, thank
Yeah.
you.
Thank you.
Thank you.